Hello, I'm Neeraj. Today I will explain the concept of graph-based RAG. Just to consider a very simple scenario. Suppose you have a very big private data and you want to use that private data to get the answers for your query by using large language models. Then what will happen? Several times you will find that the contextual documents that you extract from the private data is not appropriate. Sometimes those contextual documents may not contain the sufficient amount of information. Sometimes you will find that the contextual documents that you retrieve from the private data shows a very good matching for your query, but it is not means like a top ranked document which can actually answer your questions. And several times you will find that the answer of your query is spread at multiple different places in your private data. Means your question is a multi-hop question. Sometimes you will find that your query covers the conceptual information spread in the entire data. So in all those scenarios, it is very tough to take the entire big private data to just answer for a given query. Even if you take, it will be the wastage of resource and you will not get the appropriate answer for your query by using large language model. So what is the solution? The solution is graph-based RAG. So there are a lot of methods developed in the area of graph-based RAG. So I will just give you the basic pipeline that almost all methods in this area are using. So what all such methods are doing, they take the big private data and after that they convert that data into a knowledge graph. For that what they do, they take the help of LLM, extract the entities and their relations, and based on all those relations, entity relation triplets, they prepare the knowledge graph. So now your big private data is in the form of knowledge graph. Now suppose your user query is find the cheapest hotel near a historical place. So in that case, first task is to extract the entities from the query. So your entities will be like name of name of historical place and hotel. You will search in this knowledge graph and identify the entire subgraph or community which are highly nearly connected or closely connected with those entities like historical place name and hotels. So in that way you will find a community which contains the historical place name and all the connected hotels and their price. Now extract that things here. So in that case now you have a subgraph which contains the sufficient informations that may be spread in a multiple different part of the text. So now you got the entire information in the form of a simple community or a knowledge graph, subgraph. Now we can generate a summary from this knowledge graph. So how to generate the summary? First way is to take the shortest path between some two entities like hotel to historical place. So take all the shortest path and each path will contains like starting entities, age information and the closing entities. And if there are some other entities are there, then it will be like that. So it will form a meaningful text fragments. So extract all such kind of text fragments. Otherwise just use the triplets like a starting entity E1 relation R1 and then entity E2. So relation R12. That way extract all the entities and then concate it with each other. And after that this will be your summary. So next part is like embed all those information. So why I am saying to embed all those informations? Because the entire large language models contains all the informations in the form of some embedding. So some text embedding they are already using. So we will use some embedding library, similar embedding library or same embedding library to embed our generated summary. Now we take the big private data, same big private data, but in embedded format. That is again embedded with the help of some text embedding system which are similar to large language models embedding. Then we fire a query to this big embedded private data. The query means we have to identify the similar text fragments in the embedding format from this private data. So here it is like a vector search, because here after embedding your summary will be a vector format. The data which contains the big private data in the embedded format, this is also in a vector format. So by using cosine similarity or some similarity measures, you will get the appropriate information. So now your data will contain all the text, even scattered in a multiple different places, but it will collect all the entire informations which are required to answer your query. Now you use your query prompt, again embed it and pass it here. So here it is your prompt and here it is your data. So now fire it to large language model that we want answer for this prompt in the context of this data, and the large language model will give the appropriate answer. So this is a traditional and a successful way to handle such kind of large scenarios. So now I will explain the entire thing through a very simple coding example. But before going into the detail, we say that what are the additional development in this area. So the recent development in this area is like that. We find that some latest published papers like GraphRAG, this paper actually claims the scenario RAG generally fails on a global questions directed as an entire text corpus, such as what are the main theme in the data set. So to answer such kind of questions, the authors of this paper proposed a very good method. In that method, they take the source document, apply some text extractions and chunking. After that, they take the text chunks and then they use some domain tailored summarization. And after that, they extract the elements of the instances. Like we had in our case, we had extracted the entities. Then from the domain tailored summarizations, they extract the element summaries, and based on those element summaries, it identifies the graph community, and again it applies the domain tailored summarizations and again compute the graph summaries, and through some ways it finalizes the query focused summarizations. So the query focused summarizations contains the general community related answers. So they pass it this query focused summarizations and get the global answer. So this is one of the way to handle this scenario. Now we will try to understand that how such kind of strategies like a pipeline to use the graph based RAG, how it is working. After that, it will be very easy to go through this paper and implement this paper or understand the implementation and work of this paper.